David Smith here with one more flipped classroom math lesson. 3 tips. First, you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to catch up with your notes or jot down some questions. Third, you can turn on the captions and read my words on the screen. Today's topic is a review of the sequences and series and the financial solver problems we did in chapters 5 and 10. Let's take a look at our first topic, arithmetic sequences and series. And pause the video. What's the difference between a sequence and a series? Okay, sequence is when you're just talking about the terms. Calculate how many terms, calculate what the terms are, what the common difference is, things like that. Series is when you're talking about the sum of all the terms. So the main thing about an arithmetic sequence is a sequence of numbers separated by a common difference. So either you're adding the same number every time or you're subtracting the same number every time. That grows arithmetically, and another way to say that is it grows linearly. So if you graph these points, they would make a straight line. Okay, let's take a look at a problem. Actually, here are our 2 formulas. The nth term formula is simply the first term plus n minus 1 times the common difference. Pretty straightforward. Now the sum formula has 2 versions. N over 2 is the same in both of those, but this one is good if you know the nth term. So if you've got the sum, say, of 8 terms and you know the 8th term, then this one's pretty simple. You just add the first and the nth term and then multiply it by n over 2. Pretty straightforward. But if you don't know the nth term, then you can use this formula. It's a little different. We have the n over 2, but now we do 2 times u1, and then to that we add n minus 1 times the common difference. Okay, so let's do a problem, or a bunch of problems. Here's what we're going to be given. u1 is 27, and u2 is 35.5. That's all we're given. And we're going to do these 5 problems based on that information. So if you're feeling bold and adventurous, pause the video right now and see if you can do these problems, okay? Otherwise, we'll do them one step at a time. Okay, nth term formula. Check it out. We need to know the first term, which we know. So un is going to be the first term, which is 27, plus n minus 1. Now, this is the nth term formula, so we don't plug in any numbers. We just do n minus 1 times d. And what's our d? Getting from 27 to 35.5, we're adding 8.5. So this is just n minus 1 times 8.5. Okay? Pretty straightforward. That's the nth term formula. Super cool. Find the 4th term. Again, pause the video at any point during here if you want to do the calc before I do it. So 4th term, we're going to write u4 equals 27 plus 4 minus 1. So that's going to be 3 times 8.5. And that kind of makes sense. We're at the first term. We're going to add 3 common differences to get to the 4th term. So go ahead and do that calc and see what you get. I get 52.5. So if you can't get that, try again. Make sure that you can wind up at 52.5. Okay, moving on. 3rd question. 86.5 is which term in the sequence? So they're saying this number is one of the terms, and you're being asked to find what that term is. So again, we're going to use the same formula, and we're going to plug it in a little differently. We know the term, we just don't know which term it is. So that is 86.5 is going to equal u1, which was 27, plus n minus 1 times 8.5. So to do that one, you just have to do a little bit of algebra. Subtract the 27 from both sides, do distributive property, subtract the remaining, and you'll get n. So what I get when I do that, pause the video, do the calc. So I get n is 8, which makes it the 8th term. So next one, find S12. So that's the sum of the sequence all the way up to the 12th term. So now we're going to use this formula. We don't know the 12th term, so we can't really bump into using the easiest formula. Now, you could calculate the 12th term first using this and then plug that in, and use that, but I think that's more work than just going to the better formula that's more suited for the task at hand. So let's do our plug-in step. S12 is going to equal 12 over 2. That's this part here, n over 2, times, and I use parens here, 2 times u1, which is 27, plus n minus 1. N is 12, so n minus 1 is 11. So it's going to be 11 times 8.5. Close it all up. So now do your calc and see what you get. Okay, so when I do that, I get 885. Action. All right, let's attack the toughest one here. Okay, this one requires the use of the calculator. So check it out. If 1452 is the sum of our sequence, that's a finite sequence that stops at a certain number, how many terms are there? So this sequence with this starting number and this common difference will generate a sum. We don't know how many terms it takes to make that sum, but it will generate a sum of 1452. We're being asked to find out how many terms does that take. So let's do our plug-in. If we know 1452 is the sum, then we write 1452. Now we don't know n, so we have n over 2 times 2 times 27, that's our u1, plus n minus 1. Now we have to just use n minus 1. n minus 1 times 8.5. Okay? Oops, and we need our closing paren. Now, this is going to generate a quadratic equation that we need the calculator to solve. I want you to pause the video and crunch that down. See if you can get it all the way to the quadratic equation with 0 on one side, with 0 on the left-hand side. Okay, I completed one more step, not all the way there yet, but I just wanted to break it down so you could see what happened. The first thing I did is I multiplied both sides by 2 to get this 2 out from under the n. So I have an n there now, and I multiplied 1452 by 2, which gives me 2904. And then I simplified what's in the parentheses. 2 times 27, that was 54, but I also did 8.5 times n, and I did 8.5 times negative 1, which is negative 8.5. So I subtracted that from the 54, that was this. I have 45.5 plus 8.5 n. Now, pause the video again and see if you can reduce this down to one quadratic with 0 on the left and everything else on the right. All right, so now I did all that. I moved the 2904 to this side, so I just subtracted it from both sides, so that generated that term. Then I did my distributive property here. I multiplied n times 45.5, which gave me 45.5n, and I multiplied my n times 8.5, which gave me my n 8.5n squared. Now, this is a tough one to factor. This is not one to try to do algebraically. This is one to pull out your calculator, navigate the menus to the polynomial roots section, and pump in the 8.5, the 45.5, and the minus 29.04, and then that will generate an answer. So go ahead and do that. The steps for that are in a prior video, so go ahead and do that and then see what you did. Okay, when I do that on my calculator, I get two answers. One of them's negative. It is a true solution to this quadratic equation. However, negative n's aren't part of sequences. We just count from the first all the way up to whatever term we're interested in. So whenever you do that on the calculator, you throw away the negative number and you look at the positive number. And in our case, the positive number is 16. So there you have it. That's 5 questions dealing with an arithmetic sequence and series. All right, let's go through the same sequence, this time with a geometric sequence and series. So we have a little different thing. We don't have a common difference, we have a common ratio. But before we go into that, just know that the IB questions are made hard by not going through it in a very methodical way that I'm going to tell you now. They're going to start a question with like one of these later ones where they give you some value of some term and they're going to ask you to figure out what term it is. And all they're going to give you is the second and the fourth term. And so you're going to have to realize that you need to figure out your R, your U1, so that then you can use the formula, and so on and so forth. Okay? All right, so let's do a quick review here. The nth term, or general term formula, for a geometric sequence is just the first term, U1, times R to the n minus 1. Pretty straightforward. It's actually fewer moving parts than the arithmetic sequence, but it does involve exponentiation, or using exponents. Now the sum is straightforward here as well. U1 times R to the n minus 1 over R minus 1. And you can reverse these two, U1 times 1 minus R to the n over 1 minus R. Either one will work fine. I like this one just because I like my exponents first, but that's just me. Both will work just fine. So let's take a look at our problem. Here we go. We've got U2 and U4, okay? Now, here's our first question. Find R and find U1, okay? So here we go. The way we do that is we could pretend that this is U1 and that this would be then what? U3, right? So then we can go U3, 911.25 is going to equal U1, which is, or U2, which is 11, well, we're calling it U1, 1125 times R to the n minus 1. So if this is term 1, this would be term 3. So n minus 1 in this case would be 2. So that would be R squared. Now what we're going to do, actually pause the video and see if you can solve for R. Okay, so what I did is I just divided through by 1125, divided into that, and what I get is 0.81, so that's R squared. Then we take the square root of both sides, and we get 0.09 is our R, okay? So, but now we need to find U1, okay? So now we can pretend like this actually, we don't have to pretend. This is U2, so 1125. Actually, there's a quick, well, let's just do it this way. It's a little bit more involved, okay? So U2 is 1125. That's going to equal U1 times R to the n minus 1, which is just 1.9. 0.9 to the 1. So that's just 0.9. So what we do now is we just multiply, or we divide both sides by 0.9, divide by 0.9, divide by 0.9. That cancels these out, and we get U1 is going to equal whatever that is. So what I get is 1250 is my U1. Okay, so now I've found everything I need to write my nth term formula. I know my R and I know my U1. So that brings us to question 2, write general term formula. So all I do is I write UN equals U1 times 0.9 to the n minus 1. Now that's the formula we can use to find any term. That's why it's called the nth term, or the general term formula. Sweet. All right, so now we need to find U6. This is a straightforward plug-in. So go ahead and pause the video, do the plug-in step, do the math, see what you get, and then come back. Okay, so here's what I get. I get 1250 times 0.9, there's our R, to the n minus 1, which would be 5, because n is 6. And if I do that math, I get 738.1125. Now, in this case, I'm not rounding, because this is a term in the sequence. So if I were to round this to 3 sig figs, I'd just say 738. But really, in this case, I want to say what that number is because that's the term in the sequence. Now we're going to say, use the formula to find n for 820.125. Pause the video, plug the formula in, and see what you get. If you feel bold, go ahead and solve it all the way down till you find the n. So there's your plug-in step. We know this is our term, we just don't know the n. And it's going to be found by multiplying 1250 by 0.09 to the n minus 1, whatever n is. If you haven't gone further than this, pause the video now and crunch some more numbers. I'm going to actually give you a little tip here before I turn you loose. If you have ax equals b, so you know a and b, but you don't know x, then what that is that's log a of b equals x. And for this, you do need the fancy schmancy calculator, so that you can put in log to a different base of b, and you'll find out what your x is. So pause the video, write the log equation, and then solve it. All right, so here's my log equation. Log of 0.9, log to the base 0.9 of 0.6561 equals n minus 1. So that's the trick there. One other thing I remember is that the power has a base. that base is the base of the log. So base, then you throw the other number you need. Now this is a weird thing about logs. Log base 0.9 of 0.6561 is 4. Weird, right? But that's what it comes out to be. So I have 4 equals n minus 1, finish the algebra, and n is 5. So the fifth term for this sequence this would be the fifth term of the sequence. Okay, last one, let's do a sum. So S12, go ahead and pause the video, do the plug-in step, crunch the numbers, and see what you get for S12. Okay, here's how I did that. I did my plug-in step. S12 is going to be U1 times parentheses around R to the n, so that's 0.9 to the 12, minus 1 over R minus 1, so 0.9 minus 1. So crunch that on your calculator, and what I get is 8969.63. That is rounded, but that's a sum. So we can round a sum, and we're not throwing away anything. This one we couldn't round because that's exactly what that term is, so we need all those decimals. All right, let's do a financial function calculation, but we're going to do this using the formula with algebra, and then we'll move on into using the solver. Okay, so here's our formula. Future value equals present value times this term in parentheses, which is 1 plus R over K times 100 to the Kn. Now let's look at some of these things. Future value, present value, pretty clear what that is. R is the yearly interest rate. Don't turn it into a decimal. And then K is the number of times compounded per year, and I left N out. N is the number of years. Okay, so we're going to do 2 calcs here real quick. We're going to invest $25,000 at 8.25%. How long until it doubles? Okay, so we're going to compare yearly compounding to daily compounding. Okay, so let's do a plug-in step for yearly compounding. Pause the video and put that together. All right, here's my plug-in step. Doubling 25,000 gets us to 50,000, so that's the amount we're shooting for. So that's going to be 1 plus 8.25 over K times N. With yearly compounding, K is 1. Okay, so I did do 1 times N, but that's just going to simplify down to N. Okay, so go ahead and finish this calc out and see what you get. All right, so I get this function, this equation, by simplifying this down. I divided through by 25,000, so I got 2. Whenever you're doubling, you know you have 2 on one side and the rate raised to the power. It's pretty straightforward. Now we have a log equation, so I take this base and make it the base of the log, and then I take the number out here by itself and put it with the log, and then the n, our exponent, is by itself isolated on the right-hand side of the equation. Put that in my calculator, do the log. I get 8.74. This is yearly compounding, so it's going to take 9 years to double. Okay, now let's do this with daily compounding. Pause the video and do your plug-in step. Okay, so here's what I get. My double, 50,000. Here's my original, my present value. Now I have 1 plus R over K times 100. So K is 365 because it's daily compounding, 365 days in a year, times the 100, and that's raised to the Kn, so that's raised to the 365th power times n. Okay, so there's our plug-in step. Now go ahead and do the calc, and let's see what you got. Okay, let's see how you did. One correction I need to make. I put R there, I changed that. I put the rate there because we know the rate, so that goes there. I did my crunching. I divided through, got my 2. I figured out what this whole thing was. That's 1.000226. Carry a lot of decimals into this. It's going to make your log better. Don't round that to 0002. You're going to lose some resolution. Your answer won't be so accurate. Okay, so then I wrote my log equation. Log base of the big long decimal of 2 equals 365n. So that gives me this number, 3067.67. Divide through by 365, and I get n equals 8.4 years. Now remember, this is monthly compounding. So we don't have to wait all the way to the 9th year to have doubled our money. It's 8.4 years. So what I did is I multiplied 0.4 times 12 months, and that gave me under 5 months. So we need to go to the 5th month. So it's going to take 8 years, 5 months for this amount to double with that interest rate, with daily compounding. So check it out. We double a little sooner with daily compounding, which is what you would expect. The interest is added more frequently and it starts earning interest for you sooner. So it grows faster. Okay, the last topic we covered in these chapters was using the financial solver to answer complicated financial annuity and amortization type questions. So I think we're going to do a couple of those right here. The hardest part of that was figuring out where to plug your numbers into the calculator. So before we start, I want to mention, here's two little bits. If you're using the Inspire, the way you get into the financial solver is you press the menu button, then you go to the finance option, and then you go to finance solver. And that brings up the screen where you can enter all these variables in there. On the TI-84, you press the apps button, select the finance option, and then select TVM solver. Either way gets you to a very similar screen on either calculator. Okay, so I'm not going to do these problems on the calculator. I'm going to leave that for you because we did explain that in an earlier video. Okay, so here we go. Here are our variables. So before you do these problems, you have to have a firm grasp on what the variables are. Otherwise, you're not going to put the right values in the right places. So here's our problem. An annuity will pay $5,000 a month at 4.5% PA, which stands for per annum, which itself stands for per year. So that's telling us that this is yearly compounding. It's not a monthly interest rate. This is the yearly interest rate. So that's yearly compounding. That's going to influence what we put in there. The monthly payments need to last for 30 years. So basically what we're saying is we want an annuity that has some amount in it. That annuity, the money in there is going to pay 4.5% per year. And we're going to draw out $5,000 a month, and we want that to last for 30 years. Okay? So that's somebody's plan. They're thinking they're going to retire. They're going to live for 30 years in retirement. They want $5,000 a month during that. So what they need to know now, or what we need to know, is what is the initial value of the fund? In other words, how much money do we need to shovel in here so that it will pay $5,000 a month for 30 years? So here we are at the crucial step. Here's the variables. I want you to pause the video, read the problem, think hard, and go ahead and populate these fields with what you think belongs there. Number of payments, 30 years, but they're coming out each month. So that's going to be 30 times 12. 30 times 12. In the 84, you could just put that in there. I think probably in the Inspire too, but let's just multiply that out. What's 30 times 12? It's going to be 360. So we're going to get $365,000 payments. Kind of nice. Interest rate, that's just right out of the problem. That's 4.5%. Present value. That's what we need to find out. That's the initial value. That's what needs to be in there to start so we can pay these monies out every month for 30 years. So we're going to put 0 in for that. Future value. At the end of 30 years, how much is left in the account? Nada, nothing, zilch. We're going to put 0 there too. This is payments per year. So this one is 12 because we're getting $5,000 a month. And compounding per year is 1. And what did I leave out? If you saw payment, you're right. PMT. That's $5,000. And since it's coming to us, that's a positive number. Okay? Now what you want to do on your calculator is zip up and put the cursor, the highlighting, in the field you're after, and then go ahead and hit enter and let the calculator do the magic on the calculation. So if you haven't already done so, do that. Okay, let's see what you did. I get $997,330.62. So a little bit shy of $1 million. That's a lot of money. Okay, one last problem, which is actually 2 problems, but it's interesting. Okay, so all the same stuff is here for your reference, our definition of variables. Here's our problem. So we're going to use $3,000 loan at 7.5% to buy a motorcycle. Okay, so we're borrowing $3,000. We have 2 payoff options. We can throw $200 a month into it until it's paid, or we can make 24 equal payments. Okay, so let's check that out. What I want you to do is pause the video and populate these fields for this situation. We don't know the number of payments yet. That's what we need to find. So interest rate 7.5%, present value is minus 3,000. Our payment is $200 a month. Future value is going to be 0. Payments per year is 12, and compounding time per year is 12. So check this out. Put the cursor here for number of payments and press the solve or enter. Okay, when I put that in the calculator, I get 15.8 as my result. So really we're gonna have to make 16 payments. It'll be the last payment will be a little less, but we're gonna have to make a 16th payment. Okay, so now let's compare that to making 24 equal payments. Okay, so let's find out how that works. Pause the video, populate your numbers. Okay, in this case, we don't know the payments. So that's what's going to be 0. And, did that wrong. That's 24. Okay, so 24 equal payments, interest rate 7.5, present value is minus 3,000, payment we don't know, future value is 0, and these two are 12 like before. So put the cursor in the payment field and press the solve button. And if you do that, you're going to get 134.98 or 999. It's going to round to 135 per month. So what I want you to do, pause the video and figure out which is the better deal. Okay, let's see how you did. Now I took some time to do this kind of perfectly. 15.8 months of $200 a month payments means that we're going to pay 15 $200 payments. That's $3,000. And then we're going to pay 0.8 more because we're going to have a little balance left over. So we're going to pay another 160 to fully pay the thing off. So we're going to pay 3160. Now on this other one, we have a lower payment. We have 135. So that seems nice. That helps with cash flow. Every month you don't have to shovel out quite as much. But 135 times 24, we're going to pay 3240 over the course of the loan. So we're going to pay more interest with this one than this one. And financially, that makes sense. If you can make a higher payment on a debt, you'll pay it off, you'll pay less interest, and you'll pay it off sooner. Now that you've watched the video, take a moment to jot down some notes, some questions, or a quick summary of the content. You can also re-watch the portions of the video that were a little bit challenging. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.